So now you have, from this state, you'll get an extra machine made, and one machine will be now in state 2, and the copy machine will be in state 3. But for the DFA, the equivalent, it will represent that situation as a set 2, 3. Okay? So you have a machine, one of them is in state 2, for the NFA, and the other machine will be in state 3. So the state of your DFA now will be this. Okay, that two there means that there's a machine in state 2, an NFA in state 2, and there'll be another branch, a different, the same NFA, the same machine, the same automaton, but its state will now be in 3. So now you're talking about like this. This is the DFA, big D, equivalent of the state that the NFA is in, with 2 machines. NFA machine will be in state 2, and then the second, the copy, will be in state 3. Right? So for the D, this state goes to that one when A inputs. Okay. And why? Because in the NFA, state 2 goes to both 2 and 3. Well, you can see that. 2 goes to 2 and 3. Right? On input A. And we can't go further from 2. Nor 3. You can't go beyond 2 or 3, because both 2 and 3 have no eta arrows. Okay? The only eta arrows is from 1. This one here. There are no eta arrows from this or this. Okay, so you can't go any further. Okay. All right. So now we're down to here. All right. Now what is this state? Now this is a state of D. Remember. What does it do when a B comes in? Okay. So here we're talking about when an A comes in. So what does this state do when a B comes in? So now this state here, the set 2, that's a state of big D, your DFA, right? So to figure out what this state changes to, we need to look at what's inside. That 2 there is the state of the NFA, right? And what does it do when a B comes in? So we're here and a B comes in. Well, we just go to state 3. And 2 and 3 have no eta arrows, so that's it. So 2 will go to 3. Okay. So the D state equivalent to that NFA situation would just be 3 here. Okay. So the NFA state 2 will go to NFA state 3, and that's modelled, if you like, by the DFA, with a set. So we only have one machine. And we had one machine here, and now we still only have one machine. One NFA processing. Okay, so that goes to that when the input's B. Why is that? Because in the NFA, 2 only goes to 3. And can't go any further from 3 because there is no eta arrow. Okay? You can't go further. There's no, you can't jump like that because there's no eta arrow to allow you to jump. Right? So set 2 goes to set 3. That's it. Alright, so we have analysed what state set 2 does for D, because there are only 2 inputs, right? The alphabet is just A, B. Right, so we've a lot of details, right? We're only just getting started. So we know that goes to that on A, and we know that the same thing goes to that on B when B comes in. All right. What about state 1? What does it do? Now this is the state of D. Well, what happens when A comes in? You're in state 1. and an A comes in, it dies, right? Because there's no output for A. There's no output for A. There's a B output, there's a zeta, an eta output, but is that correct? Let me just check. It goes, to the null string, and it doesn't, it dies effectively on the A. Why? Because there is no A exit arrow. There's no exit, there's no arrow coming out of this with labelled A, so it dies. That's the convention. Okay, so it just dies. Alright. Now what about B? What does this state of D do when the inputs, the input symbol coming in is B? What happens then? Well, let's have a look. So I on B, well, you just transit to 2. Okay? And now 2 has no etas, so you just stay. So set 1 goes to set 2 for D, big D. So set 1 goes to set 2 on B. Alright. Okay, now here's, as I mentioned a bit earlier, here's where I was quite, put 3 exclamation marks here. I'm wondering, did I miss something when reading earlier, or is this a quirk from Sipser? But and I've quoted him in full here. Note, the procedure in Theorem 139, what we're doing in the proof of that any NFA has an equivalent DFA. That was that proof. Okay. It specifies, he says, that we follow the eta arrows after each input symbol is read. Well, that was news to me. That's why I put this there. So perhaps I should go back and read it a lot more carefully. I challenge you to do the same. And my question is, is this? Did he say this? Was it implicit, or this was a surprise to me. So this is a case of the devil being in the details, right? So hence the 3 exclamation marks. And he also says there's an alternative procedure that you can follow. You can follow the eta arrows before you read each input. Okay. So I didn't pick up, and I'm not sure that Sipser stated either. Perhaps I should look more carefully. But that surprised me. And I was saying earlier that I'm a bit fuzzy on the use of the eta arrow, and here's a critical detail, right, about that use. But I didn't see that before, and I'm wondering, did in fact Sipser spell that out? Maybe he didn't. Maybe he did. Perhaps I'm not the only prof making mistakes. Maybe I'm falsely, unjustifiably accusing Sipser of making an error here. I'm not sure. But you check it out. Check it out. Okay. Right. Well, now Sipser does state these 2 ways of you can follow the eta arrows after you read the input symbol, or you can follow the eta arrows before you read the input symbol. And he says the 2 work equally well. He doesn't say why. So I said, there are more detail. I think there's more here than meets the eye. Right? There are more subtle details about this use of the eta than he's putting in the text so far. Anyway, so again, I just hope that by solving lots of problems, these